Hi, everyone. So how many of you wake up every day and think about LLMs and RAGs? Okay, and then how many of you think about data systems that power them? See, now I got to change that part, right? Because ultimately, it's the data that's going to drive all these things into production. So when, um, so when we started working back at Intel on the data, what was happening with AI, that was a time around ImageNet becoming very popular. And it was very impressive, 1,000 classes that it could recognize from pictures. And then you come across something like AlexNet, which thinks that your brain is a dial telephone. That is where we used to be. Then as we started working on Aperture Data, we came to a situation where the models could actually recognize complex activities from complex data. So you give it videos and it'll tell you the activities that were happening. Fast forward to today, not only can the models detect and understand what's going on, but they can actually answer your questions. So what are we missing? The problem is LLMs hallucinate, models can get answers wrong. So across the hundreds of conversations we have had with data scientists and data engineers, the moment they think about driving things into production, the big question comes back to data and how they can ensure data quality. So we have a lot of new use cases. We have shockingly advanced models and agents that we are all discussing about. But ultimately, the challenges around data and the dream requirements remain the same. You want to be able to collect all of your data into a unified backend. You want to be able to search it with different modalities. You want to be able to easily manage your data sets. If you train models on some data sets, you want to be able to associate them with the data sets you trained on, not lose track of data provenance and where your derived data comes from. And of course, you want the data system to just seamlessly work with all the machine learning systems you have. Unfortunately, this is where data and therefore AI quality go to die. That might sound drastic, but across bunch of different calls, when you talk about production deployments, this is what ends up happening when you want to go from input data of any kind. You talk about text, images, videos, audio, and you want to go into either better trained models, data you want to analyze, or even recommendations or searches you want to do. You have to go through this what one of our customers actually called a ball of mud infrastructure problem, because you have to take the data, land it into some cloud buckets. The metadata goes into databases. You might have labels or annotations that you need to incorporate and again pass around buckets of data, and then write scripts to go search and find the right buckets of data and make sure you're handing over the correct thing to the right people. Just to make it more complicated, you might need to process your data with complicated libraries. And of course, we have all heard about the importance of vector databases. So if you want to find something similar, then you bring in vector databases, which, by the way, today you'll have 100 choices to pick from. So in all of this process, just from getting from input to valuable output, you've essentially wasted a lot of ML and data scientists and engineers' time. And very often, you lose the opportunity to really capitalize on what this data could bring you. And why is, let's take a look at why this would be a problem, right? We've all been kind of working with this sort of infrastructure, but never before had you had to access so many different varieties of data to feed into something for the models to start acting human, which means if you can't query your data easily, it's hard to understand, and it's equally hard to debug where the problems come from. And at the same time, if you want to ensure consistency, now think back to that data infrastructure picture I showed you. How do you ensure consistency when every one of those pieces of data tools offers a different consistency model and you are writing translations among them? Similarly, if you go through manual process of handing over buckets, and it just always used to surprise me, why do people still do that? But that's the way they have today. Cloud buckets to labelers, cloud buckets back to get your labels, cloud buckets to transfer data sets. It's just hard to scale when you have such manual processes. It delays what you really want to achieve. And this is a problem that enterprises think a lot about, hard to ensure compliance. When your data is all over the place, you don't even know how many times it was replicated and where it was replicated. How are you going to make sure that you deleted everything you needed to delete? And think about data set management. Whether you are doing classic machine learning, fine-tuning your models, or you're building something for Gen AI, you would need to, probably a lot of you have gone through this problem. We recently encountered this with a customer. It takes weeks to get permission to one database table from which you need to fetch your data. And imagine you have to keep getting permissions for multiple tables, multiple different buckets, and then you can finally create your data set for which you need to allocate a big enough machine with a lot of resources. And that is a lot of time lost and resources wasted, which means sometimes data scientists don't even want to refresh their data because it can really take a long time to produce anything. Then, when you create copies, if you are breaking down videos into frames or you're modifying the data into the suitable formats, then you're creating copies, which means sometimes you lose provenance on where it came from. So all of this leads to subpar AI outcome, which means it's lost value from all these advancements that we are seeing. And this was just for text. The moment you mix in unstructured data types like images, videos, imagine how complex it becomes. Now, of course, I'm saying all this because we kind of took all of that and took those lessons into the design while building our own database back when we started at Intel. So what we realized that there are three key pieces to this. You need to be able to manage multimodal data. So whether it's text, PDFs, images, videos, audio, you need a place that people can query, interact and store that data and query for it via database queries. In fact, we started working with computer vision data for this when we started. So we even have very easy processing functions for them to fetch pieces of it. Then the other key piece is to be able to query by metadata, which very often for a lot of applications is very connected. And so you need a graph database. And we have an in-memory graph to allow you to query whatever you're looking for and build your knowledge graph on top of this. And then the third key piece is a vector database, because very often you want to find things by content similarity. And then we tied it all together with a unified API, which is what lets us provide this unified interface for people to manage all of their documents, images, videos, metadata, and embeddings behind a single API. And of course, with a database that's purpose-built for the emerging multimodal applications, it's very easy to integrate it into your entire machine learning workflow. We envisioned it as a unifying backend for your entire pipeline. Now, I just want to show a quick preview of whether we solved data scientists and data engineers' problems. You can very easily go look at graph-style metadata. You can explore your data sets through a very easy interface where you put your query constraints and you can see images, videos on the same interface. You can ask questions. This is our recent integration with LangChain, where you can create RAG or non-RAG answers to your questions. You can search with multimodal embeddings. This uses clip embeddings to say, I want to find pictures of pizza with friends. I'm asking a text question and getting all my image responses. It helps you prepare really complicated data sets pretty easily in single queries. Training becomes a simple matter of fact of specifying constraint filters on your data and then just feeding it into any of your machine learning frameworks. It's really easy to go back and see where are your annotations, what's going on with the data set, so that you can figure out why the model is not behaving the way you expect. At this time, we've been building pretty rich set of integrations throughout the machine learning pipeline, and we are always happy to add more based on what our users need. So really, the conclusion is the right sort of data pipeline can shift your focus from spending time on data arrangement and data set preparation to actually understanding and making good use of that data. So, conclusion, use the right foundational data systems when you're building for multimodal AI. You can go ahead and scan the QR code for more information, but we also have a virtual booth. You guys can go find more information there.